All right, welcome everyone. This is a great turnout. I'm really pleased. For those who don't know, I'm Jason Breyer. We kind of got a mix here. I got this slide, so I kind of cross posted this as a. So if you don't know, I'm an assistant professor at the CUNY School of Professional Studies in the Master of Data Science program. I've been there now full time a little over a year and a quarter or so. Been adjuncting there for I don't know how many years. Um, Also, Kim and I, were running the Albany R users group for many years, but it's been kind of dormant for, I think I saw 2019 is the last time we got together. And I guess there's been a pandemic and in-person meetings are hard and life is hard. So we thought maybe we try to kickstart this. I also have, I see some familiar names, some students in here. Um, so I did this in the spring with the MSDS program. So it's a very similar talk to what I did in the spring, kind of an overview and introduction to the Shiny package. So feel free to kind of throw your name in the chat and introduce yourself. I'd like to have more of these kind of get-togethers. So if you're interested in giving a talk anywhere from like, even if it's a short thing, we could do kind of a little symposium kind of thing maybe after the new year. That would be great. I have an idea for another talk in February that I could give. But yeah, welcome everyone. So why don't we dive in and feel free to, if you want to unmute, you can unmute and ask questions. You can ask questions in the chat. I'll try to monitor that. But I'm happy to take interruptions at any point, clarification questions. Sort of the overview of the way I was going to work this is I'm going to kind of give you an overview of what the Shiny package is and what the structure is and how it works. And then I'm going to try to do a live demo. I'm going to try to create a Shiny app live and we'll see how that goes. So why don't we just dive in? So, well, I hope everybody has some experience with R, because I'm going to presume you have maybe RStudio running and can run some basic commands. So at its most basic form, Shiny is an R package, but it's an R package designed to help you create interactive web apps. And so personally, I use these all the time. I create, as well, I'm going to do a demonstration today, like little Shiny apps that are a great way of interacting with some data or to demonstrate some statistical concept in an interactive way. And I'll show some examples of some that I've done that are, sort of more kind of production or sort of public facing websites that we can interact with. So to get started, really all you got to do is install a package as you would, any other R package, and you can write them, you can run them locally. So I find a great way to start is to actually look at some examples. And so first one here is the old faithful Geyser dataset example. This is actually the Shiny app you get, and we'll look at this a little bit later. If you're in RStudio and just say, hey, I want to create a new Shiny app, this is the app you're going to get. And the idea here, or the way I tend to approach these apps, is I often have some kind of data visualization or some kind of analysis, and I want to tweak some either parameter to a function, or maybe I want to change a variable I want to look at. So in this case, we have Old Faithful. And if we're looking at histograms, this is a great little example to show, how binning, how wide each bar in a histogram is, can kind of, influence or change the perception as one has. And so on the left side, all we have is this little slider. We could say, well, what if we have 16 bins instead of 30? If we go down to 4, right? Or we can go all the way up to 50. And sort of as this input changes, if you're familiar with the histogram function, all it's really doing is changing the bins parameter to the hist function from this value. And so we'll see how Shiny kind of handles that for you, and you can make those changes. Let's get to the next slide. Here's a slightly more advanced one that I'm currently working on to kind of look at different distributions. So this is a common topic in the intro stats course. And so here we're looking at the normal distribution, in fact, the standard normal, because I have a mean of 0 and a standard deviation of 100. And we often talk about, where p-values come from. And so if we go one standard deviation to either side, we get roughly 68%. And, I could tweak that and say, okay, well, then we often want to go 2 standard deviations. So I can change this little parameter. and change the area under the curve. And, I get my classic 95%. But we can also do all sorts of other things, right? If I'm working with, say, IQ, right, and where I have a mean of 100 and a standard deviation of 15, and I can change the bounds here and change the plotting limit. So I probably would want to go something like, say, 80 to 120. That might not be enough. Let's say 130 and 70. Right. And so you can kind of change these parameters. We can work with other distributions like chi-squared. So this is very much a work in progress, and happy to share the source code to this app if that's of interest. So those are some kind of basic examples. You can go to the R Shiny gallery. I think there's lots of really fantastic, and this is often how I start. I go around here, go through this gallery and say, I like the layout here. And what's kind of great is you can play with the app, and then you can go in and get the source code and use that as your starting place instead of the template. Here's some more advanced ones. So this is future mapping. Let me make sure that comes up. So this is an application I wrote in collaboration with some folks. We can do some live transcriptions. I never tried that. In collaboration with the Youth Studies Project, where this is meant to run on a mobile phone. And so we have youth in New York City who go around and want to identify key locations in the city. So they can come in here and say, drop a location. We can use location sharing. So you're going to see where I live here, somewhere in Albany in a moment. Right. And they can go in, they can pick a picture from their phone and submit this as a kind of an interesting location. And then we kind of show these on a map. So we can say, here are all the locations across the city that youth have identified. And we can click these and kind of look at them. We can display subway lines if we want to orient ourselves. And we have lots of other kind of data layers that we can add on here, including youth study results, which is kind of another app I've written for the same project, where we've been collecting all this data from youth across the city. Right. And so we can look at some demographics. So we have multiple years of data. And here, what I want to look at is I just want to look at various descriptive stats based upon key variables that we're collecting, and we can do that. And then there's a whole bunch of different surveys. So really what I'm tweaking here is, well, I want to pick a question a year, and maybe I want to do some kind of, let's pick something like, what would make things better where you live is one of the survey questions. And, what are the differences based upon, say, gender or sex? And this will come up in just a moment. So these are the kinds of things you can do. So probably used to making these kinds of graphics in R, but what we want to do is make them a little bit interactive as we go through. Bruce Dudek is on the call. I use a lot of his apps. I like this one because it gets a little bit fancy. If I go to 2 numerical values, he even managed to be able to do 3D plots in Shiny apps, which I think is super cool. All right. So what is, I want to dig into a little bit to the anatomy of a Shiny app. What are the different components? So in its most basic form, we're going to have something that defines a user interface, and then we're going to have something that defines the server or business logic. Those are sort of the major components. And there's a couple of ways we can structure our app in terms of R code. One way is we can just have a single R script that is called app.r, and the R that's kind of has to be that name. So let me just, so the recording I'll post, let me just answer a couple of the questions that are coming into the chat. I'll post the recording. I have a link at the last page, but I'll also post it to the meetup page where this is, and also to my course website. Someone's asking can I increase the font size? I can't really. If I increase it, everything will flow not very well, but I will certainly post the slides later for you to look at. And actually the source code, because this slide deck is in fact a Shiny app and has embedded Shiny apps. So an application template. So we need to, of course, load the Shiny package. We define a user interface, which is going to be calling some kind of function, a layout function, and we'll talk about those in a moment. We can define a server function, which is going to handle all of the business logic. That's where we're going to create the figures, the tables, anything that's kind of dynamic. And then we just call this Shiny app function with the user interface and the server functions. So those are the basic components. We can structure it a little bit. When apps get a little bit bigger, it is nice to kind of organize them in separate files. So the other option is you can have two, and then optionally a third R script. And so UI.R is where we would put all our user interface code. Server.R is where we're going to put all our business logic. And then optionally is this global.R, which contains code that's common to both the UI and the server. So global.R actually gets run before both UI and server. So this is a great place if you're going to load in data sets and do any kind of data manipulation. You probably want to do it in global.R. That gets run once as the application starts up and then is reused as multiple users come in. And hopefully that becomes clear in a little bit. So if we go back to the sort of the old faithful app, which is the default app in the RStudio, when you create a new app, we can look at the different components. So in the UI.R for Old Faithful. So first we're calling this Shiny UI. So this is just telling R, what follows is going to be the user interface. And so we just have this nested function call. And here we're going to define the layout. That's often the next component. And I have a slide that talks about some of the different layouts. Here we're just doing the most basic, which is a fluid page. And so with the fluid page, we're going to define, and the reason why it's fluid is Shiny's kind of designed to be adaptive to different screen sizes. So as you make the screen more narrow, so if you're looking at an app on a phone, things kind of flow in a natural way that makes sense for a phone versus if you're on a super wide screen monitor. So we got to give our app a title. And then here we're using a sidebar layout where we're going to have some controls on the left and usually some output on the right-hand side. So this is generally a great place to start. And so we're defining the sidebar and we have an input, right? And so we're going to talk about these in more detail, but there are a whole bunch of these functions that are something input, whether it's we want text input, numeric input, slider input, checkbox inputs, right? So we got a whole bunch of these. There's some commonalities between all these functions. The first one is going to be the input name, which is going to be converted to an R variable at some point. So that first parameter really should follow the rules of naming objects in R. So don't use spaces, don't use special characters. It has to start with an alphabetic character. Then the second parameter is the label. That's what the user is actually going to see. So that should be somewhat descriptive. And for an input, we're going to have a minimum and maximum value, and value of 30 is sort of the initial. What's the default as it starts up? We have some main panel, and then here we're going to talk about all the different outputs, right? So we have inputs, and then we're going to have a whole bunch of outputs. So we have plot output, text output, table output, et cetera, et cetera. And so in this case, we're just going to have a single plot, and this is going to be the name of the plot, which is going to be defined in the server. Okay, so on the server side, really, we're just defining a function that has 3 parameters: input, output, and session. Session is technically optional, but at minimum, you need an input and an output. So as you can imagine, the input object, which both input and output are really just R lists, okay? And so the input is going to give us all of the different elements from the UI side. So all of these something input functions that have a name are going to be, the values of those inputs are going to be on the input object. And so we can work with that, and we're going to put some stuff on the output. So to correspond with, say, something like a plot output, well, we need to render a plot, right? And so here you can see I have an output. So I'm using that object, $displot. So this name corresponds to the name over here on the UI side. So this displot is the same as this displot. And so Shiny handles that automatically. So on the UI side, it knows, okay, all of these objects are should be on the output from the server. Okay, so just if you're familiar with R list, that's really all this is here. But I need to render a plot, and the key piece here, right, is well, here I'm defining the bins, and I have this input $ bins, right? Because as I mentioned, input is a list, and bins is a value as defined here by the slider input. And so that's the variable part, right? And so this histogram is going to change based upon this value. And in the next section of the talk, I'll talk about what reactive programming is and how Shiny kind of does some of this for you. But for now, all you need to realize is as the user changes this value, Shiny is going to automatically figure out that, oh, well, this render plot is using this particular input. When that input changes, I need to rerun all of this code. And so this code gets rerun, and the plot updates as the user changes things on the UI side. All right. As I mentioned, the global, this is an optional file. I tend to use it quite a lot. This is where I load all of my R packages. So my UI.R and server.R don't need to have a whole bunch of library calls. I just put them all in the global. This is where I'm going to load data. If I have an app that needs to use a database, this is where I'm going to define the database connection information. I'm going to do any kind of data manipulation. I would like to get the data in a format that I can most quickly create plots or tables or any kind of output I want, because otherwise the user has to wait for that code to run. So in designing your app, you need to be mindful of that any kind, like I would never do, say, missing data imputation in the Shiny app. I would probably do that before and create an intermediate data file that the Shiny app would use so that I don't have to wait for that imputation, which is often a time-consuming process to run every time. All right, so here is a figure that kind of maps the different outputs. Right, so we have data table outputs. So these are really nice because these are a way to kind of that the user can view and manipulate the data. So if you want to use a data table, so these are actually in a package called DT that I think gets attached automatically when you load Shiny. So if you're going to render a data table on the server side, so on the left side, you can think of the function you're going to call on the server.r script file. And what's on the right-hand side is the function you're going to use to display that output in the UI.R script. So you can render images. So render images would be things if you're generating a raster image and you want to display that to the user. So then you can use an image output, which is different than a plot, right? So render plot will work with ggplot2. It'll work with the base R graphics. It'll work with Lattice. So you can do all of those. It will handle all of those different types of plot outputs. So you're going to render it there, and then you're going to have some output. And as you can see here, there are a bunch of optional parameters that you can use. Of course, you can do question mark render plot to see what all these are. Width and height, as you can imagine, are the width and the height of the image in either pixels or percentages or in inches. So you can define all of that. Render print is great if you just want to display. So I know students in my class are probably doing some multiple regressions now, or maybe some ANOVAs for their project, and you want to throw this in a Shiny app. I do this quite a lot. I'll just take the output from LM or something, and I want to just display it. So I can do that in a render print, and I would use verbatim text output. Use that because I want to use a fixed width font in essence, right? So it displays properly. We have table outputs if you want to do that. Text is a great way if you want to write a sentence, right? That's going to have some values that are from maybe some statistical method or output. You can do that, and you can. And then you have a render UI. So you could actually generate the user interface server side, and you would use UI output and render UI to do that. As you get into more complicated situations, that might be appropriate. And you can just generate raw HTML code if you wish. All right, on the UI side, we have a whole bunch of inputs that we can use. And depending on what you want to do, some of these are might be appropriate. So we already saw the slider input, but we have just simple buttons. If you want a button to do something, we can create links. We have check boxes. We have radio buttons. There are date inputs. You can upload files, which is kind of neat. Numeric inputs. This is nice. Separate from, there should be a text box, a text input where you can just enter any text. Numeric inputs are nice because it gives you, it will do some validation to ensure the number is within a range, and you can do steps. So if it's numeric and you're talking about, say, integers or whole numbers, you can get a little, Shiny will give you a little up and down button. So the user doesn't actually have to type anything. They can actually scroll up and down. Password input just really gives you asterisks on the text. You need to be careful with password is that if your Shiny app is not on a server that supports HTTPS, then it's not terribly secure. So just be warned or wary of that. So you got a lot of options here. And here's what some of them look like. So here's the numeric inputs. You can see I can go up and down. This is the slider input that we already saw. We have text input that we can do. We have text area input, which is kind of nice if you're expecting larger text. That's why it's not letting me drag. Oh, here we go. You can make it bigger. And then here's password input. Here's our date inputs. If I click in here, we actually get a calendar, which is only partially rendering. I don't know why. Or you can do a date range. Here's some more. If you want a drop-down list, drop-down lists are great because you can just start typing, so if you have a lot of items, so if I want to get to letter Z, okay, I can start typing and then select it that way. And here are, of course, just some buttons. We can have action buttons or submit buttons. If you need to format code on the UI side, because all of this is written in R, we need to use R functions. And so Shiny provides a counterpart to nearly every HTML tag you would want. So instead of using so if you want to say a H1 or first level header, you would call a function called H1 and you would put your text in the parentheses instead of using the raw HTML tag. So just be aware of that. And then layouts. I want to kind of just talk a little bit about this. I don't want to spend a whole lot of time because this can get pretty complicated and might deserve its own talk, quite frankly. So we looked at fluid page, right? And so the notion here is, and this is kind of based upon the Bootstrap framework, which is a JavaScript framework by Twitter. So if you're familiar with that, great. This kind of follows that model. But the idea here is a page is divided into 12 columns. And so you define elements to say, well, this should, if it occupies, I want this to occupy half the width of a typical page. So I would say, okay, this is going to be 6 columns wide. And what Shiny does is, well, if the page is more narrow and say, well, we're on a tablet, so we can really only show the equivalent of 6 columns, then anything in columns 7 through 12 will automatically kind of get wrapped down to display a little bit better on a mobile device. And then maybe you get to a phone, right? If you're on a phone, it may only be able to display things sort of 3 columns wide. And so things kind of flow through as you go down. So that's kind of connected to flow row and flow layout. The sidebar layout is one we used. You can do split layouts where you just want 2 sides. You have vertical layouts. There's a whole lot, but like I said, what I generally recommend is going to the Shiny gallery and kind of looking through the ones you want, right? So you can see here, here's 12 columns. And so as I, actually this won't work in a embedded R Markdown slide, but the source code is here. So you can try this when I post the links later. So you can see how this was created. So each one of these is 1 column, but if you run this as a standalone app, as I make this more narrow, you'll see columns kind of flow down. So here's a sidebar layout with tabs. This is another common approach where I want to display different parts. So here I just want to do linear regression with mtcars, right? So I can select my independent dependent variables. So here I have MPG from weight. I want to show my scatter plot. I can get a summary of the LM function. So here I'm using the text output, and then I want to display the data as a table. So so these are all just in separate tabs. I want to look at, maybe I want to change my dependent variable to, I don't know, gears. Might not be quite appropriate, but we can tweak that. Of course, now I get a different regression, and the table is going to be the same. So to see how this is put together, right? So I'm going to define my UI. So I have a title, and I have a sidebar panel where I have two inputs, X and Y, which are my independent dependent variables. And then you can see on the tab set, I have a tab set panel and 3 tabs. So I have plot. So the first parameter is the title to the tab, right? And then I just have a plot output, a verbatim text output, a table output. On the server side, right? So I need to define plot, summary, and table. So I have output plot, output summary, and output table using render plot, render print, and render table respectively, right? And so on plot, we'll just look at that one, right? So the key part here is the X and the Y are sort of what's variable in that one, right? So that's what the user's selecting on these inputs. And so I can change my independent dependent variables, and that plot gets updated automatically as with the summary. There are a whole bunch of different types of panels you can use. So this is just showing the functions that are here. I just would suggest doing a question mark on any of those if these look of interest. Questions so far about inputs, outputs, sort of the basic elements of a Shiny app?
This is Sean.
Hi, Sean.
Hi. Thanks for doing this, by the way.
My pleasure.
Just to be clear, kind of something I had been thinking about with regard to an app I'm building. When you were doing a text input alphabetically, in a sense, is that doing a fuzzy type of search? I'm trying to come up with a tool that can select from a large number of variables in a search fashion, but kind of pick out things that I might misspell.
Oh, no, I think it's literal by default. But it's funny you asked that. Just yesterday, we were working on a project where we're trying to do some fuzzy matching. There are some R packages that allow you to do fuzzy matching, but you would have to kind of code that up yourself. So when I start typing, let me see where I can find that example. It was brought to you by the letters, right? So so if I start, because I know I get that too, and right, I typed brought wrong, it kind of stopped. There might be some other, I think there's a parameter on the select input, and maybe some Shiny folks here can chime in if they know. There's a parameter called selectIze, I believe, that allows you to use a more advanced JavaScript-based dropdown. Yeah, selectIze. You spelled that correctly. Let me see here. I have RStudio. Let me just quickly. Oh no, I can't do it because I'm running this app. It's a parameter. But yeah, you can. If we have time at the end, Sean, I'll do a quick Google search on finding the documentation for that. I have used that in the past. In another app, I recently had to turn it off because it had issues in that particular app where it was rendering underneath other outputs. So you couldn't see everything. So there are all these, you can spend a lot of time on these sort of edge cases that last 5% to get your app where you want it. But that's a good question. I can look into it.
Thank you so much, Jason.
Yeah.
Hey, Jason, I had a question too.
Yeah. Hey, Daniel.
So I'm thinking about the render functions and the output functions, and I'm wondering, are they always in like a one-to-one correspondence, or can you have different output functions for a given render?
No, they're typically one-to-one.
Okay. I guess I'm just trying to understand why you need a specific output function if it's one-to-one with the render function. Like, wouldn't the fact that a particular object was rendered tell Shiny how to output it?
That's actually a good question. yeah, you would think you could just say output on the UI side, and that you could use sort of an S3 class kind of thing to determine what the render was. I don't know why they didn't do it that way. I imagine there's a good reason. Well, one reason might be is as I look at the outputs, the optional parameters, right? So images are going to have width and height where text output is not. So that might be one reason. I don't know why they didn't do that way. In some ways, I don't mind it because lets it be a little bit more explicit. And if you have the wrong one, it's going to throw an error pretty quickly instead of trying to deal with it not detecting kind of all the components correctly. So yeah, it's an interesting question.
Okay, thanks.
So I got another kind of question here. Can you a spreadsheet or CSV file count as an input? Yes, there's a well, any kind of file can be an input. Let me see if I have it right. So there is a file input, which allows the user to pick a file on their computer and it will upload it. But you on the server side, when you handle that input, you're going to have to decide how to deal with it, right? So you'll get the file extension. So I've done that where I'll do something like if the file extension is .csv, I know I can use the read.csv file. If it's something like .xls or xlsx, I could say, oh, I just need to use the readxl package to read it, right? And it's going to hopefully be in a table format. But if somebody uploads a PDF where I'm expecting, well, that might be a bad example. Let's say a PNG, and I'm expecting kind of a tabular format. I might show the user an error and say, I don't know how to handle that file type, right? So you got to have to do a little bit of defensive coding there in checking the format. The reason why PDF might be in it, you could potentially handle PDF because I've read tables out of PDFs, so that might be a valid way you want to handle it, but that gets a little tricky as well. And do you follow-up question? Will you define what an S3 class is? I will at the very end. So hang on to that question. That's sort of.
I just dropped a link in. So
oh, Kim, thank you. Yeah, Hadley will probably do a much better job of explaining what an S3 class is than I will. But if when we get into RStudio, I could show you a quick demo. It's an object-oriented framework, and if that phrase doesn't mean anything to you, then then we'll go down a pretty deep rabbit hole. So do you need to convert PNG to text first? I'm not sure what you mean by that, Sherry. If you can elaborate. So PNG would be like an image format. If you want to display an image to the user, you can do that. That would be sort of a render raster and then image output. But I don't think you need to go to text. Oh, Claire, do you need to convert spreadsheet with PNG to text first? Well, PNG, I'm assuming is an image file. That's what I meant. So on the input, it's just going to send the file. And if the user selects a PNG where you're expecting a CSV, you need to handle that on the server side. You need to say, hey, that's a file I don't know how to deal with. Select a CSV file, right? And so that would be part of it. And I might, at the end, I might have some source code I could show. I actually have an idea that would be a great independent study to create a Shiny module to handle data uploading sort of as a validation. I would like to have like a Shiny module where you get a file, first detect the type, then display the user, like, here's a preview of your table. Which columns do you want to import, right? As you can imagine in RStudio right now, if you click on a CSV file in the Files tab in RStudio, it gives you an import dialog. I would love to replicate that input dialog as a Shiny module that I could just embed in a bunch of other apps. So for students who are potentially looking for independent studies, I maybe would be happy to do that. Okay, yeah, input. Yeah, that would be a great Shiny module. All right, other questions about this? Otherwise, I was going to dig into reactive programming from a very high level. All right, so the whole Shiny framework is based upon this notion of reactive programming. So reactive programming is not specific to Shiny. It's just Shiny is R's implementation of this framework. Now, I was a programmer in a previous life, like a full-time, working on software that was shipped on CDs at the time. And when I started doing web development, we used a design pattern called Model View Controller. But everything seems to have moved now to more of a server client role. So you only have two components. Sort of the controller's been kind of eliminated now. And so Shiny is very much that, right? So you have you got to think about it. You have a client, right? Which is going to typically be the web browser, right? Whether it's on your phone or your computer, that's the client, right? That's going to capture inputs from the user, right? And then you have the server side that needs to react to that, right? As the user changes things in the web browser, the server needs to react to it and change certain outputs based upon the new inputs or the changes in the values of the input. And that sort of at a core level, what's going on, right? But Shiny's doing a lot of heavy lifting for you, right? So we have, so this is borrowed, I think, from Hadley's book, this image. I didn't create this, but so we have some input X, right? You could think of that as the server side, right? And as that value changes, right, it's going to trigger, it could trigger some arbitrary code. So we really just talked about already these render functions, right? And one of the reasons why we have these renders is Shiny, those are Shiny functions, and Shiny's kind of digging into the code that you put within that to figure out which inputs you're using. And so Shiny creates this complex map and say, here are the code chunks that are associated with these inputs. So when this input changes, it could traverse this tree or this relationship map and flag things as stale, and that needs to be executed. So render functions are going to be a key part of that. The other one are these either observe event, like in the case of buttons, that's a common approach, right? I just want to run this code and I'm not even going to render anything. I just need to run this code when the user clicks a button, right? That may end up triggering other render functions, but sometimes you just want to, in the case of my little app, this app here, right? So I have an observe event when the user clicks this submit, which is going to just save the data from that form. It's essentially handling a form submission. So that's one way you could do it. So R is going to do that. You could have delayed reactions, which is, through these event reactions. But the key is you're going to have all of these expressions. And so Shiny's kind of keeping track of that so that when something changes in the input, it's maintaining this relationship so that all of these outputs could be re-executed after that input has changed. Yeah, thanks, Daniel. Threw a link into Hadley's Shiny book. Right. So we think of this and when we talk about reactivity, we kind of have reactive sources, and we're going to kind of represent them as, this little shape here. Then we have reactive conductors, right? So these are things like reactive functions, which I haven't talked about yet, but the observe function that I just mentioned briefly, right? Which aren't really generating any output. But then we have endpoints, right? And these are all those output objects, right? And we're going to represent it here. So in the simplest example, right? In that basic old Geyser app, right? We have some input, which is the number of that we called OBS, right? And that is going to influence this output dist plot, right? And so when this changes, Shiny knows that there's this relationship here. So once this changes, I know I need to execute that. All right, so that's the simplest example, but we can have multiple ones. So here's a slightly more complicated example. So I have a plot output where I'm calling render plot, of course, and I'm calling histogram, right? And the breaks is the parameter. So I have in the input n breaks. How many breaks do I want? And then I also have this other variable, which is, do I want to display individual observations? So this is a checkbox. I know I'm not showing it here, but we can look at it afterwards. And then I also have a table output, right, where I'm rendering a table. And if I want to see the individual observations, I'm going to return the data frame. Otherwise, I'm going to return nothing, right? So I have two inputs, right? So the plot output, right? If we look at this code, is using both input and breaks and and the individual observations. So if either of these inputs gets changed, Shiny is going to re-execute this plot output. Okay. But on the table output, all I'm using is the from the input is the individual observations, right? So Shiny creates this relationship. So if n breaks is changed, table output won't be re-executed. This will only be re-executed if the user changes the individual observations input piece, right? So, inputs can be connected to multiple outputs, but Shiny's kind of managing this relationship, and it wants to be greedy, right? It only wants to re-execute code that has to be re-executed. It doesn't want to do everything every time, and that's kind of some of the more or less magic that's kind of happening there. That it kind of handles this. But as you get into more complicated situations, it's kind of nice to understand a little bit of what's going on here, because inevitably you're going to get to a point where my output isn't updating, but I'm changing this input, and why isn't that? And so you kind of think about how those relationships are defined to figure out where that gap is. Okay, here's an example where things can go wrong. So here I'm just doing, this is a simple counter, right? So I have two buttons, right? And so I have, I'm gonna have a text output where I'm gonna have counter 1 and counter 2. And let's look at how this is defined. So on the server side, right? Note, I'm defining a function. I have an input and output. So that's what every server, the server side of every app is going to be. And I can have a variable called clicks. Okay, what you need to be aware of here is inside the server function, each user, like each person that visits your website, gets a new instance of this function. So clicks is going to be independent to each user. If I had put this clicks up, say in global, that value is going to be shared by all users. So that's sort of an aside that you should be aware of. So in counter 1, okay, what am I doing? I want to render text. I'm just saying, I'm going to add one. I'm looking at add 1, which is just the name of the button, right? So I need to react to that. So this is kind of another interesting little bit, because I want this text to be re-rendered every time that user clicks this button. So I just have this on a line by itself. And so what I'm doing here is then I'm saying clicks. This is a little wonky because clicks, I want to modify this clicks, which is one environment up. I need to use 2 less thans. I can swing back to that if you don't understand, but I need to go to the global environment. So I'm just adding 1 to clicks and then returning its value, okay? And I'm doing that for counter 1 and counter 2. So if I add 1, notice what's going on here. I have 3 and 4, 5 and 6. So what's going on, right? So I click this button. So Shiny is going to go, oh, okay, I need to re-render counter 1 because it's using add 1. And it does it. It executes it, adds 1, then returns clicks. Oh, but I also need to update counter 2 because it is also using the add 1 button. So it adds it again, right? So we're going to constantly go up by 2. So how do we fix this? Well, we want to introduce this notion of a reactive conductor. So if you have sort of shared components, you're going to want to put them in sort of their own intermediate function so that the input is only being used in one kind of element. And I think it's easier to just kind of dive in here. So we have this function called reactive. I think functionally, the easiest way to kind of approach this is Shiny's replacement for the function call in R, right? If you have written your own custom functions, right, you want to extrapolate some code. So I'm going to define my own function. I have some code and it returns some value at the end, right? That's the most basic component. And let me see if I go to, oops, I didn't need to do that. I want to create a new tab. So I want to type something. let's look at, so I want to define a function. So my function is going to be, function. I'm going to have some input, and I'm going to say return hello, right? This is the most basic component. So I can define that, right? So now I have a function in my environment. And so I could say my function, actually, maybe I'll do it this way. Let's just make this a meaningful. So I'm going to say name is a parameter. So I'm just going to say paste 0, hello, name, right? And so let me redefine that. And so I can say, I'll put Jason, right? And so I must not have, what do I have missing a parenthesis, right? So that's what I mean by a function. So over here, right? So reactive is really just a replacement for that function command in base R, but it has some special properties, and that Shiny will actually interrogate and look into the function for any use of elements on the input object, which is coming in right here. So that's another kind of quirky thing, right? So I have a function, but I'm not defining any parameters, right? But I am using that input, okay? And that's okay because it's being passed through here, but that reactive function that Shiny has is expecting you to do that. And so it's going to look into your code and say, give me all the instances where you're using the inputs so that I can manage that relationship map and say, okay, if that input changes, I need to recall this function. So the function's called counter, right? And so you can see I'm going to use it just in the same way I would call a function, right? It looks like a function. I have open, close parentheses. And so in the reactive, right, I need to react to that input. Everything else is the same. But look at here. Now, when I run this, so counter is 1. And if I add 1, they now match. And why is that? Well, when I change the input, R is going to re-execute this code, right? And so you could see for each of these outputs, I'm just calling that. So I'm calling it twice, but R knows, well, I already re-executed it for the change in the input. I'm going to save that output. So I don't need to re-execute because the input hasn't changed between calls. So I can reuse this over and over in my Shiny app. And so now the counters kind of match. So this becomes a really important component when you're working with sort of more complex apps. So I almost always, right, in my apps have a reactive function, if you will, called get data. And it's just going to return the data. And that function may do a little bit of data manipulation, but then I return the data based upon whatever inputs. Maybe the user sub-selecting some stuff. And then I'm going to use that in the plot. I'm going to use it in the table output, et cetera, et cetera. Right. And I don't want to I don't want to do that data munging or the subsetting over and over for every output. I just want to do it once when the user changes the input and reuse it over and over. Okay, so we got some questions here. Okay, question is reactive conductors. What do you mean by base R? So what I mean by base R is like just in plain old R, not Shiny, not tidyverse. Is typically what I mean by that. I hope that helps. There's different variations. Yeah, vanilla R. Yeah. You didn't load any packages. What can you do? So these can also be used for performance. So here's a kind of a silly example where, we can have some slow operation. So here I'm going to do something with the Fibonacci sequence, right? So Fibonacci is a Fibonacci number is taking the sum of the previous two integers. So you have 1, 1, 2. Why can't I do this off the top of my head? And then I'm going to do 2 plus 1, I guess 4. I can't remember. I always have to type it out. Right. So here's the basic, Fibonacci, right? So I'm defining a function, right? N. So I want the nth element of the Fibonacci sequence. Well, if n is less than 3, I'm just going to return 1. Otherwise, I got this recursive bit, right? So I'm calling it recursively. And so I have this little Shiny app. And so I have the current Fibonacci and render text for the output. So if I do this, if I set input n to 30, it takes about 15 seconds to calculate because Fibonacci is run twice. Where if I separate it out into its own reactive, right, I'm going to reduce that time to a fraction, at least half as long. So that's the other reason why you'd want to use this, because you're going to save the output and not have to re-execute as you go as different render functions are going to use that output. All right, so let's do a demo. This is always kind of, this could go well or it could go horribly bad, but let's give it a try. So the way I tend to approach these things is I usually have an R script where I do some analysis, right? And in doing it, in that R script, I want to tweak some parameter. And so instead of just tweaking it in my R script, I want to do it kind of in a visual interactive way. So this is actually an app I created for teaching, right? I want to kind of explain a couple of parameters for how lowest regression works. So maybe let's start with the plot, right? So this is what I want to show, right? So here I have just sort of a cubic function, and this black line here is what's called the lowest regression line. So I have a scatter plot of X and Y. And so low is essentially doing localized regressions, and it's kind of smoothing it as you go through. But there's a couple of, it's Loess, Sherry, spelled like I put it in the chat for you. Loess. Okay. And so this is the R code that I have here. And so there's two pieces I want to look at. I want to be able to change is the center and the span. And the reason why I know, when I am anticipating writing a Shiny app, the inputs that I'm going to have on the Shiny side would become variables sort of in my R script, right? So I can copy and paste this over to here. Let's get rid of that. So if I, right, so I can do this. Oh, I didn't load the ggplot here. So if I do, I think if I do all that and I run this, right, so I get that plot that I have in my Shiny. But let's say I want to look at lowest regression at where the center is 0.5. So I can do that and I get a new plot, right? But wouldn't it be nice to have a little slider where I can change where the center is on the X? There's another important parameter for lowest, which is the span, which is, how far away from the center of points am I going to consider? So if I make the span, like say 0.7, we could see the lowest regression kind of fits a little less well. And you could see I'm considering more points. I'll explain a little bit more what's going on once I have the Shiny app built, but this is kind of what I want to get, kind of create. So I have these two parameters. And so that's the plot I'm going to want to do. So here is the process. So I'm going to switch over to RStudio, and I'm actually going to start from scratch a brand new Shiny app. So let's see here. I do new share, go to RStudio, and all right. So I'm going to go, I think I can go here so you can see it. So it's under this plus button. You can also go to File. I'm going to create a new Shiny web app. Can everybody see this dialog? Because I never know what comes through on Zoom. Okay, so I'm going to call this Loess. And I'm going to do the multiple files. So I have a separate server and UI. All right, and so you could see RStudio created a folder here in my working directory. And so here are my two files, and it had opened up for me. So if I run this app right now, right, you could see I got that old Geyser app, right? So that's just what it gives me by default. So the first thing I'm going to do is I'm going to get rid of all of this. I might actually keep some of this. So I'm just going to say this is going to be called the Loess Shiny app, we'll call it. And I am going to have a slider input over on the server side. Instead of, I'm going to get rid of that. I'm going to call this lowest plot. Okay. And then so over on this side, I obviously need to change this. So might make a couple little tweaks like that. I can run the app, see if I broke anything. I didn't. Okay. So I'm going to copy over from the slide deck. I'm going to go over to the server side. I can get rid of this. So I'm just going to put this here as a reference, or actually I'll do it. I'll put it here, right? So this is my Shiny app. So first thing this bit, right, is kind of global. So I can put that, up here because it's going to be the same for everyone, right? I'm just going to have this data frame that has X's ranging from -1 to 1 and, going through. And actually, I'm going to want to look at this data frame in all instances. So I'm actually going to create a new R script. And I'm going to actually put this here, and I'm going to save this file as, I'm sorry if you can't see, but I'll show you in a second, called global. So I created a new file called global.r. So that will be available. So looking at, right, so I'm going to have a slider input for center. So looking at our script, I'm going to start with this parameter. So I need center, and I'm going to have center. And the reason why I put that in the global is the minimum value is I can actually use objects that are loaded in this global file. So I could say the minimum is the minimum X that I have, right? So I could say minimum data frame X, and the max will be the max of data frame X. And the value will be, well, we'll start at the lowest value, and I'm going to leave step off. I might want to tweak that later, but let's just run this now and see what we get. I couldn't find Tibble. Why couldn't it find Tibble? Because I did not load. I need to load my Shiny here, and I need to load, I'll just load Tidyverse. Okay, so far so good. Okay, Gabriella is asking, can Shiny apps be created in our Markdown type files? And yes, I'll show that in a second. So let's try to run this app now. Yay, right? So now I have a slider, and it looks like it wants, so I do want to define step because by default it must be 1. So I can stop this. I'll go back to the UI and say, I know step equals, say, we'll go on 0.1 increments. Maybe that's enough. Yeah, we can probably make it smaller later. All right, so far so good. So we have that. Well, and what's the other input we want? I'll also span. So instead of a slider input, let's do a numeric input. I love the autocomplete. So I can say span. That's going to be the variable name. I'm just going to call the label would be span. And I'm going to do question mark numeric input. Because I can't remember all the parameters. So I am also going to have a min. Now, we could look at the lowest regression, but I'm going to make the minimum like something like 0.1. I'm going to make the maximum something like 3. And the step will be, let's say 0.1. And the value is 0.3. Is that what I set as the default here? Yeah, 0.3. So I think that's a good place to be. And so I can run that app and look at that. So now I have a numeric input. I have no outputs yet, right? I have this lowest output, but if we look over here on the server side, nothing, right? So what do I need? So I'm going to need this code. All right, so let's copy and paste that into here. And I'm going to run the app, and I'm pretty sure this is going to fail. Can't course closure vector type double. So why is that? Well, I just cut and pasted that in, but I am expecting this center, right? Center and span were variables. Well, all I have to do here is say, well, those are on the input. So I need to say input center. Let me find all the places I'm using that. And then I have input span, which I'm using in 2 different places. right? So so what I had to do is change where I use these variables to the input in the variable name. Let's see what happens. Did I get this? Yes, look at that. So now I have a little app, right? So you can see for Loess, so the way Loess regression is, it's going to go from left to right, and it's essentially weighting points around that center point to calculate a linear regression. And then it's going to use the value from the fitted value from that regression at that center point for it. And it's just kind of iterating through, right? And so as I slide the this over, you can see as I go left to right. And so the intensity of the color of these points is the weight for that point in the value. So when I'm at negative 0.9, right? So these points here are going to be considered a lot, but these points over here on the right-hand side, not at all, right? Not even going to consider these points in estimating the regression. And so I can kind of go left to right, and you can kind of see how Loess regression is kind of drawing and figuring this out, right? And if you've never encountered Loess regression, when I first did this to myself, I go, oh, of course, right? I can see the weight. Now, how is the weight determined? Like how far? And that's the span parameter. So as I increase the span, note I'm going further away from that center point, which is why as the span gets larger, right? And if I go span large enough, I think 3 might be enough. Right? You can see the overall, that black line is the overall Loess. The blue line is sort of the localized linear regression, right? When the span is really large, I'm considering most of the points, maybe 3 wasn't large enough to get, to a point. If the span's large enough, in essence, Loess will just converge to what you would get from a basic linear regression. But being able to kind of interactively change these values, I think it helps explain how this works. And hopefully this process of creating this app, right? This is typically how I encounter doing Shiny apps. I have this R script, and now, oh, I want to tweak these couple of things. And that's kind of that process. I go from that step to that step. So Sherry's asking weights points around the center point, right? So the center is saying, so when I call Loess here, right, it's doing it for the entire span of values in the X and, in the X and the Y. But what I'm trying to do is, okay, so how does it determine right here that that the Y value of the Loess, in essence, the fitted value from the Loess is at that point? Well, it's estimating what you can think of as a localized linear regression. And here what I can, what's kind of nice is, so 3 wasn't large enough. So we'll go to 30. I can rerun the app. So now I should be able to go to 30. Oops. Right. That's, well, almost, right? So it doesn't, as I go across, it's going to be fairly, the Loess regression, which is black, is pretty linear. So that, there are a couple things is you got to hopefully see how Loess regression works, but I hope this helped in terms of going from an R script to a Shiny app, right? So I have this output, a couple of inputs, and then sort of defining my data here. So questions about this? So someone asked, can you do it in R Markdown? So here, so in my class for my students, I tend to use Jeringen as my preferred slide format, which is also R Markdown. But unfortunately, Jeringen doesn't support embedded Shiny apps, but IO Slides does. So the answer is yeah. So here you could see, so this is typical R Markdown. I have some YAML, which is my metadata, and I'm just defining some custom style stuff. We're going to skip over that, right? Pretty standard stuff, right? So here's some standard R Markdown stuff, but let's go. So here's where I'm running that Old Faithful app. So there's a couple of ways you can do it, right? So, and I will share this entire folder later today, and I'll send a link out. So I have this folder called Old Faithful right here, and I can open that and I can run it, right? It's a Shiny app. It's got a server and a UI as one would expect. But I can just embed it directly in my slide deck. So I can do it this way, which is through an app directory. Or, well, I'm not evaluating that one. So let's find one that I'm running. Note that I can actually use those Shiny inputs and outputs. I can just display them in line, but they don't really do anything unless they're within a Shiny app. So here you can see I have another app that I wrote that shows those layouts. Actually, let's look at that real quick. Quick digression. So here's a single app. So if I run this, so here we could see, note as I change the width of the viewer, right, how things kind of then flow down. So that's kind of the advantage of that. So that, I'm glad we looked at that. I thought I had another one. Yeah, here we go. So here I'm defining, I can just define all of it kind of inline and just run the Shiny app from our Markdown this way. Oh yeah, thanks, Lucas. I'm not entirely sure on how to pronounce that, but last time I went to the RStudio conference, it seemed like nobody there including you who wrote that package knows how to pronounce it. So it seems like all pronunciations are acceptable. But yeah, that was a good question. So you can embed it inside our Markdown files. And so I'll give you the source code to the slide deck and you can kind of look through that and see how I did it. Other questions? And if you want, if I could do this live, we could have done this interactively. I'm in the wrong, I shared the wrong file. Hold on. Let's go here. So in the slide deck, I do have the solution. Might not be exactly. Oh, you can see I even separated out the get data, so you can look at that. Happy to stay on and answer other questions, but let me quickly go. So here, these are just some resources I use all the time. Now, in terms of deployment, you got a couple of options for things like this app here and that future mapping where I need kind of more high availability. I tend to prefer DigitalOcean. And this is if you have basic sysadmin, if you're comfortable with Unix commands, this tutorial should be pretty straightforward. But that's kind of one way. I find DigitalOcean a lot easier than Amazon AWS, and it's not terribly expensive. So that's one way if you want to host them there. You can also do I have a Shiny app in here? I don't. There is in RStudio, there is a deploy. You can deploy to shinyapps.io, which is an RStudio run server. You get up to so many hours free per month. So if you're just looking to share something with yourself or with colleagues, that might be one way to go. I have a link if you want to deploy to AWS. This is, I think, a blog post I wrote. Another thing this is the one I did. So I have a package for my course where I have a lot of Shiny apps. And so they're actually embedded within an R package. So this is a little write-up I did on that, on how I deploy them as packages. So you can just install the package and run it, which is kind of a nice way. Golem is another framework for building what they call production grade Shiny applications. It's what would typically be called an opinionated framework. But I know a lot of folks in the R community like it. So this might be something worth looking into. So some of it has to be, is it just an app that you're going to use for yourself? I do this quite a lot where I have some templates for just to do descriptive statistics and kind of explore my data. I want to change some variables around and do bar plots and scatter plots. And so that, I'm just going to run it locally and that's fine. And then I have some things that I have my own server. So this r.breyer.org is actually running off of Mac Mini next to me. And so I have RStudio running and I have some Shiny apps that I can just run off of there. So that's another way of doing it. So there's a lot of options and I'm just giving you some resources to find that. There are a lot, this is, there's a pretty rich community, I think, around Shiny. So there's Shiny themes. And like I said, if you go through the gallery, some of them are really, you wouldn't even know they're Shiny apps. And they are certainly capable of doing production grades. I mean, you can even do password protection. So here's an app that I've written in collaboration with Cornell University. And so I can see if I remember the password, right? So the whole app needed to be password protected, but you can see this is looking at special education data across New York State. So you can do some sophisticated things. So I could share that. I actually didn't include that here. DT Edit is a package I wrote if you want to edit data tables. DT is, sort of the fancy approach to viewing data tables, which is a JavaScript library, which I don't quite. You know what I could show? If I go to, say, Capital Region, and I'm going to pick Albany City School District, and I go to the region. So this is what's called a data table. And so what's kind of cool here is I can sort and filter kind of server side. I can do filtering. So I want to find schools that are identified for performance, or I can get rid of that filter. So there's and it's very easy to create this, pretty kind of rich. If you want to use Font Awesome, Leaflet is what I use for the mapping applications that I have, like this one. So this is using Leaflet, which is a JavaScript library. And this is an incredible resource I discovered recently, which is just a GitHub repo that somebody has listed all of these different, like if you want color pickers, if you want to do text editing, right? So there's virtually anything you can think of somebody has done. So anyways, some nice resources. There's the Mastering Shiny. Really want to dig in. Hadley's book, I think, is excellent. Our studio has a ton of resources. They have a cheat sheet, which is like a 2-page document. You could see the inputs, outputs I kind of just stole from the cheat sheet, and you can get there. So it's kind of what I had prepared. So I see Sean's asked a question here. I almost always break up into a UI server and global into separate files. And actually, I go even a step further in even more complicated situations. So if we look at GitHub, and let me find the repository. So that New York schools.info. So the source code for this is, this is a pretty large app. And there's a lot of, there's tabs within tabs, right? So it gets kind of crazy. So the way I organize this one is each tab. Let me see if I can put this right here, right? So you can see I have map, region, district, school, and then documentation. So you can see I actually separate the server into separate components. As you can see, I have all the output, and that's just for my own organization. So if you look at my server script here, so I have some general, so here's the authentication piece that's kind of global. But if I go to the bottom, you can see I just source our scripts. The only piece, if you want to go down this approach, is this local equals true, which is important. So what local does is it says, well, it's going to essentially run that R code as if you had cut and pasted it here, meaning it's going to run in that environment. If I don't say local equals true, it ends up in the global environment, and then objects aren't in the appropriate place. And particularly what you're going to have issues is because each of these is using, if I don't use local, and I'm like, if we look here, you're going to get an error because it doesn't know what output is, because it's not defined in this R script, because this R script would typically, without local, it actually creates a new environment, runs that R script, right, and then finishes it. So things like the output wouldn't be there. So you can think of that local as equivalent to cut and pasting that code there. That's the only little trick that hung me up early on. So that I tend to do that when the apps get really big or cumbersome. So yeah, that's kind of how I do that. No, almost always do that. Yeah.
And
so
I don't mean to take up any additional time, but are you also using apps like, packages like Renv as you're going along. And I'm just thinking about, protecting apps as you go and ensuring that you've got a virtual environment and what you're using for Shiny as you're developing.
I'm not sure. What was I missed the word. Apps like what?
Oh, I'm thinking about, the advantages of, or the need for creating virtual environments as you're developing apps just to keep them functioning over time. And I've been playing around with RENV for that purpose, but wondered if you have a go-to.
I know of it, but I haven't really played with it. So that has bit me over the years, where a package gets updated and then breaks some of my code because the functionality isn't what I expect. So I use GitHub. So when I deploy to say DigitalOcean, when I'm ready to, update the version, I typically pull from GitHub on the server. So I would check it in locally, and I would have done extensive testing. I don't have any apps right now, but I did have an app where the availability needed to be greater. I would often have 2 instances of DigitalOcean, like a testing and a deployment, which is pretty typical if anybody's familiar with software development, how you would typically do that. But the apps that I'm working with now, if they go down, except for some critical times, it's not the end of the world. I don't need to have 100% uptime, or even, whatever, 99% uptime. So, I test as well as I can locally, and then, deploy it. And, when I deploy, be prepared to have some time if something goes wrong with package version. So, you just have to decide how critical what happens if you do an update and it doesn't work for a bit. And RENV is one way to handle that. All right, I'm happy to stay on and answer other questions, but to wrap it up, there's some of my contact information. I'll post these slides both to my course website for, that should say fall 2021, not spring 2021. So my students, Anna will send an email to the MSDS students to that list, and I'll also put it on the meetup page. And if you want to save the date, I'm tentatively thinking on February 8th, I can do a talk on, doing our package development, sort of similar to this, like what's the structure, what are the tools I use to build our packages. So I think I have some folks that are interested, but I would also like to get, kind of resurrect this Albany R users group. And I don't want to be the only one to give talks. I'll happily cross post when I'm giving talks that are appropriate for the, CUNY, and you guys can attend. I'm happy to do that. But I think it would be great if we got other folks sharing some of their experience. It doesn't have to be quite as formal. It doesn't have to be teaching something. If you just want to demonstrate something, or if you're not, even if you're just learning a new R package, you want to share what you learn. We could also try to set up times if we want to have sort of working groups, maybe, periodically, once a month, every other month, have a block of time. You could come with your questions, and a whole bunch of people, we could try to help each other out. I think that would be great to kind of try to resurrect this community of our users, and well, anywhere, now that we're going to do this virtually, probably for a while. I guess it doesn't have to be limited to the Albany area, but reach out to me or Kim Spearschneider, who's on there. Kim, if you want to if you can post on the meetup page, and we'll see it, or you can email me directly and I'll share it. All right, Bruce, I'm going to reach out to you soon. We'll talk soon. All right, I'm going to stop the recording.